everyone, I am Anamika Goyal from ABES Engineering College, Ghaziabad. In today's lecture, I am discussing about the topic TCP quality of service. In this lecture, first we'll discuss about the definitions of quality of service. After that, we'll discuss some important quality of service parameter. Then last, we'll discuss about the technique to improvement of quality of service in a computer network. Here we have two techniques for the improvement of the quality of services like scheduling technique, and second one is the traffic shaping. So in this lecture, first we'll discuss about the scheduling technique for the improvement of quality of service in detail. So without further delay, let's start our topic, quality of service. Quality of service is basically the measure, or we can say the representations of the overall performance of the computer network. If I am talking about the quality of service, so it is a technology that work on a network to control traffic and ensure the performance of a critical applications with limited network capacity. So what we have to do, basically, we just want to improve the overall performance of the computer network with the help of quality of services. If I'm talking about the congestion control, so what we have to do in congestion control, basically we just try to remove the traffic in the network. What is traffic? Traffic is nothing but it is a continuous flow of the data or a packet. So in congestion control, we just try to remove the traffic in a network so that we can avoid the congestion control. But here, we just try to provide an appropriate environment for the smooth flow of the traffic, that is called quality of services. Now we'll discuss some important quality of service parameters. Out of this, there are four quality of service parameter. First one is the reliability, second one is the delay, third one is the jitter, and fourth one is the bandwidth. If I want to improve the quality of service in a computer network, so our aim is to minimize the delay or the jitter, and want to increase the bandwidth and the reliability of a network, right? So first of all, what is reliability? Reliability, it basically a technique that ensure the data transmitted between client side to server side is an accurately or in a correct manner. What does it mean? So let us take an example to understand the concept of reliability, right? So if I'm talking about the reliability, so let us suppose there is a sender, or this one is the receiver. This is what? This is sender and this one is the receiver, right? What does it mean quality of service? Suppose in sender side, we just send a segment 1 from sender to receiver, right? And then sender will wait certain amount of time, that is called timer. Okay, timer. Before the timer end, if the receiver will send an acknowledgement, means sender send up a segment, and after that, if sender receive the acknowledgement, so that is what this is reliability. If a given amount of time period, if sender will not receive an acknowledgement, so sender will guess that it may be possible that the data will lost. So if I want to achieve 100%, if I want to achieve 100% guarantee to receive our packet in a correct or ordered manner, so we have to use TCP protocol, that is transmission control protocol, right? So next one is the delay. What is the meaning of delay? Delay is nothing but it is a time to reach the segment from source to the destinations. So to understand the concept of delay, let us suppose a segment will arrive in a network at a time 0 seconds. Suppose this segment will reach to the destination at 4 seconds. So what is the delay here? The delay is 4. And another segment will come into the network, that is in 1 second, and it will reach to the destination in 5 seconds. So here again, arrival time is 1 and the departure time is 5. So here in that case, what happened? This is the delay. It's 4. So basically the delay is nothing but it is the time to reach segment from the source to the destination. I hope to clear the concept of delay. Now third one is the jitter. So to understand the concept of jitter, basically jitter is nothing but it is a variation in delay, right? Jitter is nothing but it is a variations in delay. How can we understand the concept of jitter? If I want to improve the quality of service in a computer network, so what we have to do, we just minimize the jitter. So first of all, understand what is jitter. Suppose a segment 1 S1 which contain 4 frame, right? Frame 0, frame 1, frame 2 and frame 3. The frame 0 arrival time is 0 and the departure time is 4, right? Again, the frame 1 arrival time is 1 and departure time is 5. Frame 2 arrival time is 2 and departure time is 6. Frame 3 arrival time is 3 and departure time is 7. So in that case, you can see what? The delay is 4, right? When the time to re-segment of frame from source to destination is constant. So that is nothing but it is a delay. It is what? It is delay, right? Now what is jitter? Jitter is variations in delay. Suppose the segment whose contain 4 frame 0, 1, 2, 3. If the frame 0 arrival time is 0 and the departure time is 4. Similarly, frame 1 arrival time is 1 and departure time is 6. Frame 2 arrival time is 2 and the departure time is 9. Frame 3 arrival time is 3 and the departure time is 11. So here in that case you can see the delay is 4. In that case arrival is 1 and departure is 6. The delay is 5. In that case arrival is 2 and the delay is 9. Delay is 7. So what happened here? Here is it is nothing but it is a jitter. Why it is jitter? Because here variations in delay. So if I want to improve the quality of service, so we just our goal is to minimize the jitter. Suppose like you can if whenever जब like if अगर हम YouTube पर कोई वीडियो देख रहे होते हैं, in that video audio and the synchronization between audio and video signal is mandatory. Suppose video packet come first and audio after that. So what happened? The lip movement is in different direction and the actual video content is in different direction. So what is it here? Here it is a delay between audio and video packet or video segment. So this is nothing but this is called jitter. I hope you understand the concept of jitter. Right? Right. Next one is next quality of service factor is uh, bandwidth. Bandwidth is nothing but it is a maximum data transfer rate. It is called bandwidth. Different kind of applications will require different bandwidth requirements. Suppose I want to send mail from another my friend which who live far away. So in that case, my bandwidth requirement is minimum. Suppose I want to do video conferencing with my colleague. So in that case, my bandwidth requirement is more. So these are the some important quality of service parameter. I hope you understand. Now, there are some technique that can be used to improve the quality of services. There are two important technique for the improvement of the quality of service in a computer network. First one is the scheduling technique and second one is the traffic shaping. So in this video lecture, we'll discuss scheduling techniques in detail, right? First scheduling technique is FIFO queuing, right? First scheduling technique is FIFO queuing. FIFO queuing, here FIFO stands for first in, first out queuing. In this technique, what we have to do here, packet wait in a buffer. Buffer is nothing but it is a queue. It is a first in, first out queue. So here in this technique, packet wait in a buffer in, first out queuing until the node or processor is ready to handle them. This is what this is FIFO queuing. To understand it, let us discuss the flow chart of this technique. Right? So according to that flow chart, here you can see this is what this is the arrival time of a packet in a network. Suppose the arrival time one segment is came here in the network. The arrival time of a segment 1 is here. Now, first what happened? First, the network will check the condition. If the queue is full, so what happened? We just discard this segment as 1, right? If the queue is not full, so what happened if the queue is not full, so this segment will add to the top of the queue here. See, because queue is a first in, first out queue. So here the segment will come in this queuing and now processor will pick from the top of the queue top of the queue these segment one by one, and then departure 8. So what is this? This is called FIFO queuing. Here you can see that this approach does not create the congestion in network, because in this, if our queue is full, so we just simply discard the packet. If there is some space in queue, so we just add the segment into the queue, and one by one processor pick the segment and process it, and after that it will departure it. So this is what, this is FIFO queuing. This app, this is the this technique basically remove the congestion control in a network. Now it is so that we can improve the quality of services. Second scheduling technique to improve the quality of services, it is a priority queuing. In priority queuing, what we have to do in this, we just assign some priority on the basis of the information contained in a packet. According to the priority number, we can create a different queue for each kind of priority process, like high priority queue, low priority queue. So what is here? Packet in priority queuing are initially given a priority class. Each queue is specific to a priority class. So what happened here? First processor will pick the process in the high priority queue. After that, processor pick the lower priority queue packet, right? So to understand this concept, let us discuss the flow chart, right? So, according to that the flow chart, again what happened when the segment or process arrive in a network like S1. So, first of all, what happened? First of all, we just classify these segments. Suppose in a network, two segments S1 and S2 at the same time arrive. Segment S1 contain the TCP packet and segment S2 contain the ICMP packet. So you all know which packet got the higher priority. TCP packet here, like S1 packet to TCP packet have the higher priority, so it will goes from the higher priority queue, and S1 and S2 it is a lower ICMP packet which is a lower priority, so it will goes from the lower priority queue. So first of all, when the with the help of classify, we just classify the segment on the basis of the information contained in this segment, right? So ICMP segment goes from lower priority queue, and TCP segment goes to higher priority queue. So first of all, when any segment come into the network, first we'll check if the priority if there is a space in the priority queue, right? So if there is not a space in the priority queue, the packet will discard. Otherwise, packet will add it into the top of the queue. Similarly, if there is a space in the lower priority queue, so the process will add it into the top of the queue. Otherwise, will discard it. After that, the processor will pick first the higher priority queue segment. So the first of all, processor will pick the higher priority queue process first. This switch turn to the other queue when the current one is empty. So until and unless higher priority queue is not empty, processor will pick one by one process from this queue and then processes after that departure. Right? After the when the higher priority queue will empty, after that processor will take one by one processes or segment from the lower priority queue and process it and then departure it. So this is the concept of priority queuing. So if you see this concept, so there is a one problem in this approach. What? In this queuing method, there is a problem of starvation will occur. The starvation is nothing but it is a basically a indefinite amount of waiting time. In that case, suppose if a higher priority queue contain lots of amount of processes or a segment, so what happened here? The lower priority queue process execute ही नहीं कर पाएगी. This process will wait indefinite amount of time. So this will create the starvation problem. So to avoid these problem, we use another scheduling technique. This is nothing but it is the weighted pair queuing approach, right? So wait queuing method is it's nothing but it is the variations of priority queuing approach. Here we use some weighted value which will assign to each of the queue of a network, right? So here, to understand this approach, let us see the flow chart. According to that flow chart, right? Wait a minute. Hmm. So, here you can see, we use Q. For the first Q weight value is 3. It means at a time, the turning switch select 3 brackets from the first queue. Here you can see the second queue whose weight value is 2. So at that moment, the turning switch, this is what? This is the rotating switch. This will switch at a time, select 2 packets from this queue. And if I'm talking about the third queue, which is the lower priority queue, the weight value is 1. So rotating switch will select one packet from that particular queue. So the entire procedure will be the same. Suppose the process will come into the network. First will goes to the classifier. These classifier on the basis of the information contained first check if the queue is full. If the queue is full, will discard. Otherwise, will assign the higher priority process into the Q3, whose weight value is 3. Similarly, medium priority process will given to the queue, that is the weight value 2, and the lower priority process will given to the Q1, which is the lower priority queue, whose weight value is 1. Here you can see, here is a switch that is called rotating switch, which will select one by one processes from the available queue and then given to its processor. Right? So here the weight value W will represent the number of packet processed by the processor. So you can see in first queue, switch will pick 3 packet. In second queue, switch will pick 2 packet. In the third queue, switch will pick one process and given to the processor. Now processor will process these process and then departure it, right? And then departure it. So this is the concept of weighted weighted pair queuing. So here you can see processor will process each queue, right? In that case, you can see either higher priority queue, either lower priority queue. Processor will process each priority queue process. So in that case, there is no issue, just like in starvation problem and any other problem. So these are the some scheduling technique which is used to improve the quality of service in a network. These all are the references used to design this lecture. Thank you for your patience listening.